Okay, so as I told you before, the second lesson was still going to be dealing with quadratic functions and actually also graphing the quadratic functions, but we're going to look at it in a different form. So instead of doing the vertex form as we did last time, we're going to do what's called standard form this time. And actually, this is what you would be more accustomed to seeing in past courses, like for instance, Algebra 1, where it's written where it's in descending order. So the A, B, and C are just holding spots where you have numbers, and we'll have to use those numbers to help us find things. All right, first thing that I have listed is how you're going to have to go about finding the vertex. When it was in vertex form, if you remember, all we had to do was just look at it and be able to tell what our numbers were for our vertex. But we've got to do a little bit of work this time. So a couple of little notes here for you to write, not as many as last time, I promise. But finding the vertex. So it says to find the x-coordinate for your vertex, you're going to use the little formula that I have here in the box, the x equal negative b divided by 2a. So your b is going to be the coefficient of x, and your a is the coefficient of the x squared. So you're going to need to substitute these two numbers into this formula, and that's going to give you the x-coordinate for your vertex. Then to be able to find the y-coordinate for your vertex, you're going to substitute the x that you just found here back into the function, and that will tell you the y. You're also going to need axis of symmetry. It's exactly the same as it was in the previous section, and because it is like an imaginary vertical line, it will always be x equal, but it's the number, that you put here, like x equal 5 or x equals 6, is going to be the x-coordinate of the vertex. Like I said, same as it was in the previous section. We are this time going to find another piece of information, our y-intercept, and you find a y-intercept the same way here as you do with any other type of function, and you can substitute 0 into your function for x and work it out, and whatever value you come out with will be your y-intercept. So this will be the information that we're going to find for each of these. So I have them all listed here in the instructions. Identify the vertex, the axis of symmetry, the y-intercept, and then we're going to use that information to graph it. Okay, so starting out with vertex. Okay, so I need to find the x-coordinate first, and that's going to be using the negative b divided by 2a. Now, for this particular problem, remember, a is always going to be the number, the coefficient that you have of x squared, which is an understood 1, and b is always the coefficient of your x, so that would be a positive 4. So those two values need to be substituted in. So I would have negative 4 divided by 2 times 1. So of course that's negative 4 divided by 2, which is negative 2. So this is my x-coordinate. So then it said to find the y-coordinate, you substitute the x value back into the function. So you just take negative 2 and plug it into the given function. Okay, so this is going to give me 4 minus 8 plus 1. So 4 minus 8 is negative 4, plus 1 is going to give me negative 3. So my vertex is negative 2, negative 3. Okay, also tell me, remember, axis of symmetry. Now that, remember, that is a vertical line, so again, I always do x equal, and the number you put here comes from the x-coordinate of the vertex. And next, the piece of information that I want you to give me is the y-intercept. Now that is a point on the graph, so we'll write it as an ordered pair. So remember I told you to find the y-intercept that you're going to substitute 0 in for x. So like you can go ahead and put 0 as your x coordinate. So if you were to substitute 0 here into your function, of course you probably could do that in your head, you would have y is equal to 0 squared plus 4 times 0 plus 1. Therefore, you have just 1. Okay, so using this information to graph it. Okay, so we don't need many tick marks here. We don't have large numbers to have to do this with. So plot your vertex first. So I have -2, -3. And as soon as you do your vertex, I want you to go ahead and put that dotted line in for your axis of symmetry. Now remember, it always goes through the vertex. Okay, then we need to plot the y-intercept. Now the ideal thing is when you're graphing a parabola, you have the vertex, but then you also want a point on each side of your axis of symmetry. So this is where your axis of symmetry comes in handy. Remember, it cuts it in half, which means the two halves have to be mirror images of each other. So the point that you have here, there has to be a point over here that's a mirror image of that point. Now, how many units do you have between your axis of symmetry and this point? So the distance from here to here is a distance of 2. So that means this point would reflect over here and be a distance of 2. And then that gives you enough points to do a good sketch of your parabola. Remember, these are all bowl shaped, so when you come down here through your vertex, make sure that you round it off there at the bottom. Okay, next one. Okay, so let's go ahead and identify A and B. So A is the coefficient of x squared, so that would be a -1. B is the coefficient of x, which would be the +2. Okay, so finding the vertex. Okay, so we start out with our formula, -b divided by 2a. So I would have -2 divided by 2 times -1. So I have -2 divided by -2, which is +1. So there's my x coordinate. Now I substitute 1 back into the function. Okay, right here is kind of tricky for students sometimes because they want to take the negative that they have here and make that part of what's being squared. But it's not part of what's being squared because there's not parentheses around all of it. So you're only going to square the 1 and then change the sign of it. Okay, so just be careful about that. So this actually is going to end up being -1 plus 2 plus 5. So that's going to give us 6. Okay, now axis of symmetry. So that's x equal 1. And now find your y-intercept. So to find your y-intercept, you're going to substitute 0 in for x. Now again, like I said, if you can do that in your head, that's fine because you're going to substitute a 0 here, which will make that term 0. You're going to substitute 0 here, which makes this term 0. So all you're left with is just the constant term here, which is 5. I mean, I'll write it out, but do it in your head if that's what you want to do. All right, so now, let's see, vertex is at 1, 6. Okay, so 1/6 for my vertex. And I'm going to go ahead, dot in my axis of symmetry. And we have the y-intercept at 5. Okay, so this time, actually what's going to happen is our parabola is going to turn upside down this time. But this is the point, remember, that you're going to reflect. So the distance from here to the axis of symmetry is just 1. So I'll go 1 unit on the other side. There's that point that matches it. And like I said, your parabola turns down. So there's your graph for that one.